Hello and welcome back to the channel. It is Mark from PowerSonic and Apprentice 1-to-1. You will see here we have another all-in-one 2. This one again with the PV top box. So we've got PV coming into here. We've got 13.5 kilowatt hours of storage and a 12 kilowatt inverter. This thing is a bit of a beast. We're combining it in this video with the gateway as well. We have got other forms of generation around this property and other things going on as well. That is a really interesting way of using the gateway. Some unique features in that we'll get into through the course of this video. And just to say, if you're a customer at the start of this video looking for a system like this on your home, there'll be a link in the description where you can go off and get in touch. But without any further waffle at the start, let's get straight to it and see what this is all about.
So these are much like the all-in-one when it comes to installation. There is a couple of brackets that need to go onto the wall, and then you simply lift the carcass on there. And in this case, we've got a gravelled bed underneath. And point of note, you can wall mount these. The feet are there for stabilisation and rigidity, but you don't necessarily need to use them. In our case, we've got a concrete pad under these stones, and we've simply taken that through with some blocks. So it is sat on the floor. The PV top box drops on. You have to remove a little cover plate from the top of the battery unit, and then you've got that ready to take your PV inputs into. And in this case, there is 6 MPPTs. You're not really getting to see a great deal of them at the moment because my camera work is a little bit lacking, but they are all in there, and you can have wires entering from the rear of the top box or through the gland plate on the side. And in my case, I decided to bring them rear entry just to try and keep things a little bit neater along the side of the wall here. But it is aesthetics. It's down to our own tastes and wants with this. And I'm using some of the inner cores from PV Ultra to help identify these cables. They are double insulated and coloured white and red. We've then got our MC4 ends that come with the kit, and you need to make sure you're using the appropriate ends that match up with the connectors in the system, so it's important to do that. And we've got our male and female variations that we can crimp onto the end, and then they just simply push into the MPPT connector ports inside the PV top box. They work from 80 volts to 550 volts DC in terms of generation, and I think it's 60 volts up to 600 volts in terms of their actual VOC. We'll check that later on in the video actually and have a look and confirm on that. You can see there just popping the pins in, and we have got local isolation points here at the side of the inverter. These arrays do come off the house and the outbuilding, and there is also isolation points on those buildings as well. There is a bit of duplication there, but I think it's important to be able to isolate these things at the places they reside, both from the panel's point of view when they're remote from the building and also around the equipment where they connect into. You can see, as always, we're using the IMO isolators here, and that is our staple product. You can isolate 2 strings in one of these. They are the 4-pole variations. And then we've got our PV now wired in there. So the 3 strings, there's 2 coming off the house and 1 off the outbuilding. I think we've got 9 panels on the house on one array. We have 3 or 4 on the other, and then 8 on the outbuilding. We have got a very large AC isolator to the side of this. Although it is a 12 kilowatt rated inverter, it charges at 6 kilowatts and it will discharge to the house loads at 12 kilowatts. Again, we'll come back to that later on. And we need an Ethernet cable between the battery system itself and the gateway if you were using one. You also need your internet connectivity. You can see we have the briefcases, same as before on the older version of the all-in-one, and they simply slide into the carcass in, and that is really to try and avoid these weighing so much as they get lifted onto the wall, akin to the Tesla Powerwall. It's just an easier job getting it into position. And then you need to screw these in along the side, as you can see Nathan ably demonstrating here. And that is just to make sure that they're in the right position. And if something was to happen with the actual battery system on the wall, they are staying where they should be staying, basically. And they just screw in all the way down. You can see we've already got our cables on the AC side into the inverter as well. We'll talk a little bit about those in a moment. And we've now got our cover plate on here. And we've learned this lesson the hard way with the all-in-one. Do not use power tools on these. They line up, but it sometimes can be very easy to go slightly off square, and then you can absolutely ruin the thread behind them. So we always do these up with an Allen key now, as you can see Nathan dutifully doing and working through here. He is in his winter wear. It is very, very cold at the moment this time of year. It was a very wet and rainy day. We actually got hailstoned off through the course of this. You can see it's a bit muddy and wet on the ground there because we've also taken a duct over to the outbuilding, and that was to cover off the PV cables coming back to this system. We did have a separate inverter down there prior to this upgrade, and we just wanted to bring everything back to a central point, and it also helped us satisfy the DNO who were starting to get a little bit squiffy of the number of inverters within this installation. So we've done that, and it is a bit of a muddy, damp one due to that work that we've been carrying out. The front cover goes on as always, and there's been a few changes with these front covers from the all-in-one one. They changed it midway through actually, so I think it's probably consistent with the last version of that where the screws are on the side. And now we're just pleating and tidying up some of our cables leading up to the isolators. So we have got our two PV Ultras running into those DC isolators. One of them a 2-core, which runs off to the outbuilding for our N750 duct. And then we've also got our 4-core, which goes off into the house from the DC isolators that used to live alongside the inverter in there, bringing them to this external area. And these are SWA variations. So we've got that rodent resistance. It's really important with our DC distribution that we're trying to protect it as much as possible, and having mechanical protection around our double and reinforced insulation makes such a lot of sense. I cannot for the life of me understand why certain elements of the industry of things are working against that. I think in the end, sense will prevail. We've got our HO7, which is running off into the inverter, and we'll speak a little bit about that further on in this video as well. There is plenty of room in that low wiring compartment where there's some slack that I will draw back through later on, because we've got a bit of a tight bending curve on there. And that isn't where the actual weather seal is either, as a point of note. The top wiring terminals where all the connections are made have grommets in there that actually seal through. So that bottom plate is really just a space to bring your cables in and then spread them in and around to where they need to be. It's quite a good idea from Givenergy, and it's unusual to other equipment on the market where a lot of that space is sort of left adjacent to the inverter. There's actually somewhere to put it, and it keeps it neat and tidy. And I'm just trying to get these PV cables neatened up. You could go for some Copex around these if you want. My own opinion of them, while they are double insulated and rated to be in an outdoor environment, sheltered as this is, it makes more sense in terms of heat dissipation to leave them exposed. And we're just giving a bit of the duster rinse off there. That is the easiest way to clean these things up sometimes when it's wet and miserable. So we're all neat and tidy and ready to go and see what this is all about. Let's have a chat through it and see where we're up to in the installation.
So we have got our large AC isolator out here, and this is one that could essentially break out for a second all-in-one 2 if we want. So we've brought a 5-core 10mm down into here, and 2 of those cores are just earthed off inside the isolator for the minute. The reason being, it made sense to pull it across. It's only a shortish length running back into the gateway while we were on with it. Not an extra expense in the cable. Makes it really simple in the future when we drop another one onto here. We've got our local DC isolators on as well. So these are for the 2 strings off the house and 1 string off the outbuilding. We've got our cleats all in place, and our duct that still needs sealing that runs off to the outbuilding as well. We've also drawn in a spare data cable which links across there. It's currently unused, but while we were dragging all the cables through, it made sense to pop it in and across, and that can run off into the house if needs be, or be wired into one of the all-in-ones or any other product we pop in here. So we've got that as well. Leading off from the AC isolator, we've got our 10mm HO7, and that runs off into the all-in-one itself. Now HO7 of this iteration at 60 degrees C will carry 51 amps, and obviously this will output at 12 kilowatts, which roughly speaking is around that. We do have a high supply voltage here above 250 volts, which is a separate story, and that drags that down into the high 40s in terms of current. But because this is sort of freestanding and we're not anticipating any peaks in output at 12 kilowatts, we're not so worried about that. But you could look to size that in 16mm if you was concerned, or use a different cable type. HO7, because of its insulation properties, stops heat radiating away as well as a steel wire armour cable, for example, or NYY. So something to consider. We've got all of our strings in the PV Ultras dropping out of our isolators, and they loop into the back of this inverter and go in the PV top box. Now this PV top box just sits on top of the all-in-one. There is 6 MPPTs in it. You can wire in through these here if you want, for your individual MC4 leads. However, in this case we wanted to try and get rear entry to make it a little bit neater. Just aesthetics. Whether it looks neater or not is open to interpretation, but I felt it did. We've also got entry points for your cat cables and such should you need them down there, but again we've brought them rear entry on here because this does need a LAN cable or a Cat 6 cable going back to the gateway, and also for its internet connectivity as well if you're looking to use a hardwired internet connection. And you can see they track along the bottom here. We run up the back and they enter into the wiring compartment in here. Now that is where you make all of your AC and data connections inside that panel. It's weatherproof. There is glands on the underside of here that will basically, this doesn't need to be weather sealed per se, because it's weather sealed where the connections are. This water just drains away. You can use this without the PV top box if you want. So we've obviously got it in here because we want to bring all of the generation to the all-in-one 2. But if you want to just use this as a 13.5 kilowatt hour battery storage unit, you can. You can see you've got the same display on the front as for the all-in-one 1. Come a bit further on this way, you can see the other side. So we've got our DC MCB on there, and we've also got the reset button for if you're needing to reset your Wi-Fi. For installers out there, you'd be familiar that this used to be slightly trickier to get to because you have to open the wiring centre. It's now just in with the MCB on the side, which makes life a little bit easier for us. Your power button on the side here as well, and if you're using this as just the AC coupled, right, obviously its top height finishes there. There's a little cover plate on the top which stops any moisture ingress. There's no wires linking these, they do just stack together, which is super handy. And you can see it looks pretty neat. It's not very thick, so we can still get the bins passed down here, which is one of the primary concerns we always have with these when we're siting them in an outdoor environment. They are especially narrow, which is great, and you can see on the side here the temperature rating is -20 to +50, and we're not going to be getting that in the UK. Its max output power is shown as 20,000 watts, and that is if you're going for the 2 all-in-ones together. They will obviously output double their rating to the house loads, and you can see you've got your 600 volts DC inputs, you've got short circuit of 23 amps DC, and your PV input current at 17, which is pretty consistent. PV input voltage range from 60 to 600, working MPPT range of 80 to 550, and 6 MPPTs on there, which is really useful. For the all-in-one itself, oh sorry, that 20,000 watts is just double the top box rating for its PV input. So your rated power of the all-in-one, you've got your 12 kilowatts, which they're showing as 52 amps, and as we said, the HO7 at 51 amps. It's getting there, isn't it? But that's 60 degrees C, remember, and at 90 degrees C, if the connectors are rated to carry that high temperature, you can run HO7 higher as well. It goes up into, I think, 74 amps or something in 10 mil. So it's one to really think about in your design. Obviously, the connectors on this all-in-one are rated to work at 70 degrees Celsius, as all of our equipment is in a wiring system in the UK. But it's just something to think about. We've got the maximum charging current of 25 amps. So that's an interesting one on this. If you've just got the one all-in-one, it will only charge at the 6 kilowatt, not 12, which I wasn't aware of the first time I started looking at these. If you want the 12 kilowatt input for the charging, you need the 2 all-in-ones, then you will get that. So the 2 all-in-one 2s, you will get that. Just a singular one, it charges at 6 kilowatts, and it will output at 12 kilowatts. You can see that there where it says the maximum discharging current of 41 amps. So you're kind of in the realms there of what we've been discussing. And you can see your design energy, which you've got on there, is nearly 16 kilowatts, and your battery capacity is the 13.5 kilowatt hours, the same as the all-in-one one. And these can be used with or without a gateway. In this case, we've got a gateway because there's lots of other stuff going on in this system, which we'll be speaking about if we haven't already in the course of this video. And that all lives just inside the house there, where we've got a generous plant room cupboard that we're calling it. There's just a little bit of tidying up to do here now. Obviously, we need to seal the duct end, get some of these old plugs out the wall. There was a little shelving unit here before, and just tidy up some of the older holes, make sure it's all neat. Bottom entry and all the isolators. Obviously, we don't want moisture ingressing into these. They're the weak points in wiring systems. If they do have any kind of moisture leaking in towards them, you get corrosion on your connections and stuff. So you want to make sure you've got drain holes in the bottom, suitable IP glands in there, and where possible, you're using any fixing points that are external to the enclosures, so you're not piercing the backs of these, allowing moisture to track down the wall surface and then into your isolators. That gives you as good a prospect as possible of keeping condensation, moisture ingress, critters, slugs. Be amazed what gets in these sometimes when you go off carrying out maintenance. So keeping those points of entry to an absolute minimum is the way to go. And then if someone's coming on to work on these and wanting to take connectors out of any of this, they've got an isolation point there to do it safely. And also if a consumer's coming to this because there's a problem with the system and they want a visible, easy place to turn it all off, it's there, ready and waiting for them. Let's go look at the gateway. You can see in our plant room area here, we have our gateway, and that links into the consumer unit that's set above here as well. And you can see inside here, we have an array of additional features compared to the Gateway 1. So this is a slightly thinner but also a larger footprint on the original Gateway. The antenna is now sited on the top as well. There's no fly leads and such to wire in for that anymore, or dongles, antennas. It's all just straight on the kit as it is. We've still got the grid input as we've always had. We've still got our bypass switch, and we've still got the house loads and the all-in-one breaker itself. The key difference is all of these ports here, and these are on Wago lever connectors just inside the Gateway. But you can set that up for your EV charger, smart load, which could be a heat pump or something, for example. Critical load might be some servers. You can have a parallel in, which is for a second all-in-one too. You can have two of them on the same system. And then there's a PV inverter input as well. So if you're bringing third-party generation or using another Givenergy PV string inverter, you can wire that into this port on the AC output of that as well, and it'll be metered and measured in the same system. You've got your generator port, so if you're doing backup generation, diesel, petrol or whatever, you've got that too. So from these you drop down into some overcurrent protected devices, and you can see here we've got a couple. One is for our outbuilding, the other is for the EV charger, but this can be set up in any which way you want. Obviously we've done it like this in this case, but there's loads of different options, and we've got other circuits we're bringing into here soon, and the second all-in-one, so excuse the rather scruffy blank that's in there for the minute. That's not going to be staying like that for the long term. We've brought our cables in freestanding in here because it's a plant room area, so we've not used containment around this, but if you wanted to, it will sit on 100x100 trunking, just 150x150 to be safe. And I think we shared that in the prior all-in-one video we made with this kit first time out anyway. But as I say, we've got lots of modifications going on with this, and we wanted easy wiring access in the plant room as those changes are made. So we've kept it simple in this case. Basic principle is your grid comes in, your house loads connect out, your all-in-one connects in, and then if there is a power cut, the clever electronics in here, almost instantly, there has to be like a half waveform separation for the DNO element of things, kicks in, and your all-in-one 2, subject to its battery capacity, will run your house loads, and you won't even notice there's been a power cut. Now when that's happening, you can have other things in the system set, so the smart loads are turned on or off depending on how you want it, your critical loads are maintained, your EV charger will be booted out of the system to avoid that depleting any battery storage. And it just gives total control and customization of what you want to do. The bypass cover is currently not in position because I've been doing some other testing videos with this, but that would normally sit in there to stop a consumer interfering with that by accident, because if that's switched up, it puts a bypass to the grid and all of the figures in the monitoring and such go out of kilter. Nothing dangerous would result from that, it just means the system's not doing what it should be doing, and all of the electrons are just bypassing out to the grid. So you leave that in place so that nobody can turn that on by accident, and it's just there if there's been a huge system failure. We've never had one happen, thankfully, but if there was, the customers have got an easy point to basically restore the grid to the house consumption as a mechanical connection. It's just like a fail-safe, if you like. But it looks really neat. You've got a little reset button on the top here as well. Installers will be pleased about that one too, because you used to have to open the cover to get in there to do any resets of the comms modules and stuff. Indication on there to show that it is connected and online as well. Just various different flashing on different states based on that. And then the front is as it was before, really, showing if you're drawing battery power, you're drawing from the grid, and the power going out to the house loads, and your central green light telling you that everything is A-OK. And that is it in a nutshell with the Gateway. I think it's a massive improvement on the Gateway 1, just in its customization and capability, but also the way it commissions and goes together as well. It's much simpler, much more straightforward. Huge fan of this product, and fair play to Givenergy for getting it to this from the very first time out. It's exciting with the other products they've got on the way as well, and HEMS coming to the forefront of the sector with what could be coming in the not too distant future. And this is another stepping stone towards that. And yeah, huge fans of this product. Thank you very much for watching. I hope you found this an interesting run through the Givenergy All-in-One 2. The short summary is I think this is an incredible product. It's really well priced, lots of versatility and capability. The Gateway is the killer feature of it, allowing all of those things to be drawn together into one place. giving elements of control and customization as people make best use of their energy within their own homes. And that's the way these things are going. And as always, Givenergy are at the forefront of that with their product innovation. We've got lots of these to be on with installing now. If you're in the market for something like this in your home, there'll be a link in the description where you can go off and get in touch with us. It'll be a pleasure to put a proposal forward for you. And if you have any questions around this as an installer or a customer that you want answering, drop them in the comments. And as always, I'll do my best on those as well. Thank you very much for watching, and we'll see you on the next one.